Alright guys, today's goal: the learner will understand when to use recursive rules with sequences and functions. So far in this chapter you have worked with explicit rules, the nth term of a sequence, such as a sub n equals 3n minus 2, and a sub n equals 3 times 2 to the n. An explicit rule gives a sub n as a function of the term's position number in the sequence. In this lesson you'll learn another way to define a sequence, by a recursive rule. A recursive rule gives the beginning term or terms of a sequence, and then a recursive equation that tells you how a sub n is related to one or more preceding terms, meaning terms before. Okay, so just like before, we have an arithmetic equation here. See how it says a sub n equals a sub n minus 1, the previous term, plus d, where d is still the common difference. A sub n equals r, which is still the common ratio, times the previous term. Okay? So, let's take a look at what we're going to do with these. Make sure you copy these down. Alright, write the first 5 terms of the sequence. Okay, well, the first one's given. A sub 1 is 3. So watch. A sub 2 is a sub 2 minus 1 minus 7. Well, that's the first term minus 7. What's the first term? 3. Minus 7, negative 4. So what are you doing to get to the next term? Subtracting 7. So watch, a sub 3 is going to be negative 4 minus 7. Negative 11. The fourth term, negative 11 minus 7. So there's the first, second, third, fourth, and the fifth. Negative 25. See how they're based on the previous term? That means recursive, okay? So you need to know. Now, look at this one. This one started at a sub 0. So the first term is technically a sub 0. And it's 162. And here, a sub 1, the second term is going to be 0.5 times a sub 1 minus 1, which is 0.5 times a sub 0, which is 0.5 times 162. Half of 162, 81. So there's the second term. First, second. Now what? So the second term, you do half of the first. Or the third term is half of the second. So you get 40.5. The fourth term, half of that. So you get 20.25. The fifth term, half of that. So recursive are based on previous terms, okay? So now it says write the recursive rule for the sequence. So the biggest thing you got to do is it a common difference or is it a common ratio? So this is what you check. 14 minus 2, 12. 98 minus 14, not 12. So it's not arithmetic. So try geometric. 14 divided by 2 is 7. 98 divided by 14 is 7. So it's geometric. Check the rest just to double check, but it is geometric. So watch. A sub n equals common ratio times the previous term. Done. So 13 minus 19, negative 6. 7 minus 13, negative 6. So it's arithmetic. So this one, a sub n equals a sub n minus 1 minus 6. Because if you say plus negative 6, it's minus 6. So there's our recursive formulas. So write the recursive rule for the sequence. Now look at this one. So here I did an example here, because if we do 1 minus 1 at 0, is 2 minus 1 0? No. 1 times 1 is 1. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 2. Yeah, see, they're all different. They're neither geometric or arithmetic, so you have to just think. Okay, so look. It says, beginning with the third term in the sequence, each term is the sum of the two previous terms. Because see how you have 1 here, but there's nothing to add, so isn't 1 plus nothing 1? And then 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. So 5 plus 3, the next term up here would be 8. Okay? So look, they said the first term is 1, the second term is 1, and then a sub n equals the first, well, two previous terms, or 2 terms before plus the term before. Because see how that's adding? They say they add the 2 previous terms. To do that, you do n minus 2, n minus 1. Okay? So look at part B here. You see the 1, 1, 2 again. But 1 plus 1 is 2. 2 plus 1 is not 6, though, so it's not the adding again. So let's see, look what they did here. It says denote by the first term, a sub 0 is 1. Then note that a sub 1 is 1. Okay? 1 times a sub 0. Well, that's 1. A sub 2 is 2. 2 times a sub 1. Well, that's 2. A sub 3 is 6. 3 times a sub 2. So notice how what they did was they told us that the first term a sub 0 here was 1. And then what you're doing is you're multiplying. Think about n being 1, 2, 3, 4, 5, and then you're multiplying it by the previous term. See? So that's how they got this. Okay? So if I was going to find the next term here, it's, see, this is, so we have 0, 1, 2, 3, 4. So the next term would be, n would be 5. So if I was trying to find a sub 5, it's 5 times the previous term, 24. Okay? So, press pause, take a minute, try to figure out a pattern here. Okay? So we see we have a repeat again. So it looks kind of like the first or second one, but if we look, it's multiplication going on. Because look, isn't 2 times 1, 2, and 2 times 2, 4, 4 times 2, 8. So it's the multiplication of the 2 previous terms. So you would say, let a equal 1, a sub 2 equal 2. So then a sub n equals a sub n minus 2 times a sub n minus 1. So I know these are tricky, but we got to be able to think and apply. There wouldn't be a ton of problems like this, but we do need to try to figure out patterns, okay? So here, an online music service initially has 50,000 annual members. Each year retains 70% of the current members and adds 5,000 new members. What happens to the number of members over time? So they want to know time. Did they give us a number of years? No. So let's think. We've learned how to find the sums of geometrics and arithmetic. Well, arithmetic you have to have a start and end point, but geometric you don't. So this must be geometric. And it says you retain 70%. So if you think about that, isn't it 50,000 times 0.7 to the n minus 1 plus 5,000? But how do you find the sum of an infinite geometric series? Because even if you add the 5,000, it's not going to really matter because it's still just going to do 70%. So at some point, those are going to balance out. So you don't even need to include that. So remember, it's sum first term divided by 1 minus r. So you get 50,000 divided by 1 minus 0.7. And you would get approximately, at some point, got an extra e in there. At some point, this music service will have about 16,667 people, or members, okay? So don't forget previous knowledge, because this equation is what we went over yesterday. So, see you guys in class later.